Happy to see everybody here. This is my first live talk in over, I can't remember how many months, years. Never mind. I really hope this talk is informative, and let's dive in. So a little bit about my background. I consider myself sort of a one-trick pony who's worked way too long in one thing, distributed databases, and I really started on this journey at Oracle change capture, log replication, and that sort of stuff. And then at LinkedIn, I led the Voldemort key value store during the kind of the hypergrowth kind of phases at LinkedIn. Then had a brief stint at Box where we're building one more real-time data store, like a la Firebase. And most recently, I was at Confluent right before this journey, building KSQL streaming database. And of course, Hudi is a project that we started while I was at Uber, and been also growing the community with the Apache Software Foundation for the last 5 years. And with Onehouse, we're doing more of the same distributed data warehouses, database stuff. So that's my background. And for today, I've done a lot of Hudi talks, so that's not what we're going to do today. There's a lot of good materials out there for Hudi on the side, and you can always connect over the Hudi Slack. Instead, what we noticed is everybody knows what warehouses are. And then I used to assume that everybody knew in my own bubble that people knew what data lakes were. And over the past 1 year, I've actually realized that it's not the data community is big, and it's not necessarily the case. And then now there is the new kid on the block with the Lakehouse. So besides Hudi, we get a lot of questions in the community around general architecture, how to think about things. Should I move out? Should I stay? All kind of things. So I thought we'll take some time to talk through some of these aspects and sort of clarify some common questions here. Okay. All right. So why now, right? So why is it important to do that now? And I'm actually, over the last 2 years, I realized how big the data community has become, right? And then we have people with very diverse set of backgrounds, actually. So I have a more databasey background. I'm pretty sure a lot of you are from the Spark kind of world, streaming, Flink, and Python, as we just saw in the great keynote. And a lot of just plain old SQL. Okay, let's write SQL, right? There's also that camp. And there are lots of choices in front of us, right? So how do we pick and choose, and how do we understand trade-offs together? That's sort of what we hope to do today. And a quick overview. So we'll first start by sketching the evolution of these technologies, the arc of sort of how we got here, and sort of try to understand and study them across these 3 different aspects, which is architecture, capabilities, price, performance. And I'll leave you with a pattern that I've seen emerge. This is broadly distilling the kind of patterns that I've seen in the Hudi community for a more balanced and future-proof way to kind of build your core data infrastructure and architecture. So let's get started. So on-prem data warehouses, very simple, right? They're you can think of them as specialized databases for analytics. That's all we had. And then if you look at the other arc, data lakes really started out as a architectural pattern more than anything else, not tangible software that you can download and use like an RDBMS or a warehouse. It's more like an architectural pattern. That's how we started in the 2000s. And steadily, you've seen in the last decade, BigQuery, serverless queries, there's steadily lots of innovation has happened around the warehousing space. Redshift, in my opinion, really brought cloud warehouses mainstream as the cloud picked up a lot of momentum. And of course, Snowflake famously decoupled the storage and compute here, and with a lot of great usability. And today you have the cloud warehousing options, which are pretty mature. A lot of people use it as a staple analytics needs, right? And if you look at going back to the data lakes, really all of this started with more search and social and these kind of high-scale data use cases. I used to work at LinkedIn, again, back when we were using all of these things to process a lot of data and build data-driven products, really. And for a while, that's, like even as Spark grew and sort of revolutionized data processing, and cloud grew, a lot of the workloads, the cloud storage is ubiquitous. Data lake slowly became pretty much synonymous with files on top of cloud storage, right? And we had an interesting thing at like a point at Uber back then when we were trying to build a textbook data architecture, which is a data lake architecture, where we wanted to essentially get our operational data, our databases, event streams, and external sources into a raw sort of like layer, reflect that, and then be able to do any kind of like ETL or post-processing, derive more data sets out of it. We found that it was pretty impossible to build that textbook architecture because the core capabilities that you needed to, transactional capabilities that you needed, were just simply lacking on the warehouse, on the data lakes. And that's how the Hudi project was born. So we basically added updates, deletes, transactions, and also even like going as far to add database CDC style change streams on top of the lakes. And this is what we called a transactional data lake. That's what we called it internally back then. And as you know, right after, quickly right after, right, Databricks Delta started out as a proprietary project and then was open sourced a few years later. And over the last couple of years, I think we've seen this term, Lakehouse, really being like popularized to sort of mark this shift in technology for how we store and manage data on the data lake. I don't think we need more battles around names and terminologies. This term is catchy, and we can, I feel like we can use this to just talk about transactional data lakes. So moving forward, so why this matters now is, as a technology, I've had this question a lot, which is, oh, is it marketing, or is it there's still work to be done, but the technology foundations on what this technology adds on top of the existing data lakes is pretty proven out. So just from looking at the Apache Hudi community through that lens, right, you can see these are everyday daily services and sort of even large enterprises that you see, if you add them all together, you're looking at a few exabytes of data being managed, using a Lakehouse tech like Apache Hudi. So the tech is really there. And you might have noticed all the recent developments and all the, and as someone who started my career in watching the database wars, I found it very interesting to say the least. And okay, so how do you make sense of it all? What's really going on? And this picture actually summarizes it well. Warehouses are pretty well understood. Everybody understands what they're for. They're pretty mature. And data lakes have been in this trough of disillusionment from pretty much 2018 to 2020, till now, right? And then there's a lot of frustration around data engineering. There's too many moving pieces out there. And then Lakehouse is just an emerging category, which I believe can redeem lakes by adding some of the core missing functionality that you see, right? But we need to be also pretty cautious because this is not the first time around that we've seen a silver bullet being sort of prescribed to solve all problems, right? And I'm unfortunately getting old enough to have lived through the Hadoop Era promises, where the Hadoop Enterprise Data Warehouse, you can read these titles yourself, would take over data warehousing and all that. And to me, it was a little bit ahead of its time for the bet, but also there's a lot of focus away from solving core user problems, right? The things like Hudi should have been written way 5 years before, in my opinion. And so that's the thing. So we also need to approach it with more cautious sort of optimism. So throughout today, I'll try to kind of give a more a open, honest evaluation of where things are today and how I see the landscape evolving as well. So we'll cover three aspects. One is architecture, design considerations. What are the primary workloads? What is it Of course, functionally, everything can sit on everything, but what is it really built for? And we'll also talk about openness, because that comes up a lot whenever you talk about architectures or open architectures or a thing, right? And we'll touch upon some core technical capabilities, how well these things are platformized, what does the management look like, how much do you should plan on your team building versus like how much is already built in, how much flexibility you want versus how much is like pre-baked, like that sort of thing. That matters a lot today in terms of like DevOps and operating lean data orgs, right? And cost performance levers. So there's like variety of workloads. I'll leave you with like, what are the type of workloads? What are the design choices and how they kind of like sit on all the stacks. So let's quickly look at like the basics, which is what was the on-prem warehouse? So pretty much you had a bunch of nodes with beefy disks and CPU, and you ran SQL, which ran on them, accessed local data, right? It's pretty like, it's just a clustered database kind of architecture. The real kind of like innovation, and again, like it's hard to really picture architecture of closed systems, right? And I think more or less, I think high level, they look like this, I think. You have storage on cloud storage, which is like infinitely scalable, right? So the problem with on-prem warehouses was that the storage and the compute were coupled, so you cannot independently scale them both. Right, but in this model, cloud warehouse, they solved it really well, where you can store as much data as you want on a cloud storage with, of course, some caveats. But then you can spin up on-demand compute, and these are managed services which always keep some always-on platform services like optimizing your queries, transaction management, metadata. These help these services be more resilient. They can do a lot of globally optimal decisions. Like you may be spinning up virtual warehouses on the same table, and like you can do a lot of cross optimizations that way. So this is the architecture that we've seen. And if you now go over to the lake, traditional data lakes, interestingly, it's always had the storage and compute separation. That's actually literally how they were born. But the traditional data lake was pretty much files on top, and you had a mixture of JSON, like anything really, like, and SQL engines, essentially a bunch of nodes that can execute SQL on top of them. Depending on the engine and the vendor you use, you either had a cache or not. With Lakehouses, what we've really done is added a layer, inserted a layer in between, and track more metadata. And then you would see that it's become more structured. The world is more structured now in the Lakehouse. And essentially, we added a transaction management layer, like a bunch of things that can optimize your tables, similar to what you find in the warehouse, like clustering your table and whatnot. We'll talk about some of these later. And also like schema management or statistics, just tracking more scalable file-level statistics for your tables. And rest of the architecture is pretty much the same. And you can now see how the architectures kind of approach each other, right, from the cloud warehousing and the Lakehouse model. And openness is a big topic, right? And then it simply doesn't stop with open data formats. It extends well beyond, cuts into architecture. So of course, like open data formats are interoperable, future-proof. Warehouses pretty much more or less proprietary data formats. And interoperability is a different thing. If you're really popular, then lot of tools will interoperate with you. But with open file and sort of like table formats, what you really get is the ecosystem can evolve on its own. You're not really beholden by a vendor really adding support for some X, Y, Z formats, really. That's the key power of having open data formats. And data location access, again, it actually varies between vendors. Even warehouses, in some you store data with the warehousing vendor. On some, it's like cloud provider operated warehouses, then it sits within your account. So it kind of like varies. Lakes mostly store data in your own bucket, and with some caveats that you need to be careful about how you really set up permissions on your bucket so that you can remain owner of the objects that you've written, right? Data services is where the key differences that I find are. Most of the things that operate on a warehouse that maintain or manage your tables are all proprietary. And on the lake, even on the lake, I think there's a pattern to like keep open formats but lock everything else to like a vendor runtime. And this is something that we've done, I would say, a much better job at on the Hudi project, where you get like ingest services, table optimization, all these services are in open source, and the combination is what, at least in our opinion, locks true kind of like openness, because then just a format is a passive thing, right? What do you do with it? So on code and community, again, like, can you influence the project? Can you get, even if you have a team, like, if it's large enterprises are tied to vendor roadmaps. And even on the lake, it kind of varies by the project and whether it's a grassroots open source project or it's like a more vendor, like driven by one company sort of thing, right? So so I had a quick like sidebar on data mesh, where I get a lot of people, oh, I'm building a mesh and not a lake. So just quick thing here is, it's pretty orthogonal concept. The mesh talks really about if you remember, I said data lake was an architectural concept. It mostly talks about how you organize your data, not the data infra. So even here, if you look at even this like introductory sort of article, it advocates for data infra standardization as a key point of how you can implement a data mesh. So summarizing our architectural discussion, right? So TLDR, what I see today is like warehouses are really built for BI, where the problem is about scanning the least amount of data possible. And that's because they have performant metadata management, long-running servers. Generally, it's geared towards sort of supporting these more interactive workloads better. And if you look at the lakes support scalable AI. What it really means is they're scan optimized. They can scan vast amounts of data. That's because like all of them there are no intermediate servers, right? So they can directly access cloud storage. And open formats really mean that the kind of ecosystem that we just like talked about in the keynote, these kinds of ecosystems can evolve much more quickly because smaller projects can come up. They can be built on top of this data, and then it's easy to do that, evolve and iterate as a community. And lakehouses, in some sense, are trying to blend both, but there are challenges. I reckon there'll be like a lot more query planning, like these kinds of advancements needed. And I mean, if you Google any lake versus warehouse sort of like comparison, it'll tell you structured, unstructured, right? Lakehouses are still mostly like dealing with structured data, and we haven't even and then there's like still a lot more standardized data management and these challenges to be solved. So it's impossible to like look at every technical capability, but hopefully these slides will give you a picture and establish a pattern of the theme that you can observe. So just core reading and writing, right? At this point, all of them can support insert, updates, deletes, transactions, statistics, sorting, bulk loads, audit, rollbacks, time travel, these kinds of basic functionality you'll find in all the stacks. You'll find that warehouses have more complete like relational or database-like functionality, like multi-table transactions or clustering and these kinds of things. And on the Lakehouse, most of this tech is delivered as libraries, right? As you know, and your mileage really varies with like kind of the libraries that you use. Hudi, for example, we supported keys from the get-go because that was like a unique key constraint, was like a pretty hard requirement for us when we started it back at Uber. And then you have like space filling curves. You will find some are proprietary, some are open. And then there are some specific design choices around like streaming updates and all these things. So in general, you will see that the Lakehouse design choices reflect more around the higher scale data needs at this point, while warehouses try to stay close to the database sort of origins that they start with. The other set of things that you need is it's not just like writing a bunch of data and then walking away. You need like some services that can, at the core, optimize your tables, ensure really good performance. And I've listed some of them here, and you can see like a pattern here, right? Clustering or sorting for good performance, space reclamation. So as you dirty data, how is it like managed? And there's a huge difference in terms of how automatically managed they are, or whether you need to take some of these libraries on the lake and then run them yourself, right? And something like file sizing is completely, like warehouses hide files, right? But they are still exposed on the lake, and if you don't manage them well, they can affect your performance. And some frameworks have automatic enforcement, some are DIY. So you'll find like a mix of management gaps, or maybe like even in Hudi, right? We have these things, but you still need to self-manage it. Like Hudi can do clustering, but you need to run a clustering job yourself and kind of operate it. While if you just go with a managed service, these are like managed internally for you, right? I'm talking about caching. It's like pretty transparent, and depending on the vendor, you will either get caching or not on the lake. And there's also other things that you need to generally build a warehouse and kind of like declare it open for your company. Things like database change capture, or even ingesting log events and things like that. So here, what I've seen is a lot of people who use cloud, the modern data stack or the cloud data warehousing space, have managed zero ops ingestion services that they prefer to get data in and sort of build tables. But on the lake, people hand roll their own DBZM or DMS or some like change capture thing, tie it to a library like Hudi to build an end-to-end sort of like system and then sort of operate it. So the big takeaway here is still, if you want to build a Lakehouse today and operationalize, it does take some time. And you have to build it sort of like brick by brick by looking at all these different kind of problems and problem spaces and putting solutions together, which gives you great flexibility, but it does take some time to market for you to operationalize this. This is a very interesting topic. So price performance. So first, let's try to think about the different workloads you have. Often I find that whenever people talk about price performance, you just see some TP-CDS wars and some numbers being thrown, right? In reality, you have at least these 4 different kinds of like workloads, right? And not all of them need a premium engine, meaning your SQL optimizations aren't necessarily going to help you with ingestion, right? It's a very IO-bound thing where you can afford to not run premium engine. So we'll get into that a little bit. And different workloads have different price performance. That's what I'm trying to emphasize here. And like locking yourself to like one engine, basically you're just like buying one. And especially on the lake where you don't really you still have to do a lot of work to manage your tables, you have the optionality of picking the right engine. So for some, maybe you pick open source version, some we go with the vendor. So Lake is good in the sense that you give that optionality, but with the warehouse, it's more or less priced in, right? All of these things are priced in for you. So this is the famous TP-CDS wars that you always read, right? We're going to do something different. We're going to try to understand the anatomy of a query. So what really happens, and then how do each component in a lakehouse or a warehouse sort of like react to each of these segments, and where does the performance difference come from? So one is fetching metadata, right? So if you look at like just table metadata, schema, statistics, and like whatever is needed for you to plan and like just understand how to even plan this query. Lakehouses like store today either in like a meta store like Hive or like flat files which store like statistics about the table. And then warehouses predominantly use a database to store that. CS 101 will tell you that databases will outperform flat files for a wide range of things when the data size is like big, right? So that same laws apply. And I think it's still like early days, and we have to evolve the statistics management in the Lakehouse beyond this, I feel. Right? And if you go to query planning, then it depends on like pretty much the engine and the vendor. This is where most of the engine open source versus like vendor proprietary kind of like margins and all the competitive IP is built. And just going by the problem space, right? The query optimization is a very hard problem, which gets like better with the amount of time you spend in it. Just by that, I would imagine like there'll be like much more mature optimizers out there, and this is like an evolving landscape, right? Once you plan a query, when you execute it, if you look at it, Lakehouse, like we employ open file formats, and on the warehouse, there's closed file formats. I don't think a lot of the performance differences come from the file format themselves, but more like how the runtime of, if you do a group by query, let's say you have to shuffle data around, how does the engine do it? And even within the Lake engines, there is like huge variance, right? Something like Spark would, be more resilient to shuffle failures, retry, but something like Presto wants to keep the interactive query performance and the lower latency. So it probably like it'll fail and it'll do like different choices when it shuffles data and answers queries. So high-level answer, it depends. TPCDS is great, but I've routinely found that people run their own workloads and then they find that it's actually not, the gap isn't that big, or it isn't that small. Like, always test with your own, like, key table. Take your top 5 queries or something and then try to test that's what I would say. And this table gives you like a good sense, right? So over the base EC2 cost, you have different sort of like engines pricing differently. This benefits you when, for cost price performance, let's say your engine charges you 2x more, but can finish that query like 3x faster than the net you gain, right, in cost. But it's not the case everywhere, right? And then you need to think about, does everything need to be fast? Because caches are pretty fast as well, for example, but they cost money, right? So if you can afford to be slower in some cases, it can be cheaper as well. So it's more nuanced, like fastest isn't the thing. And when you look at warehouses pricing as well, some price by query, some price on like a different kind of virtual like instance types, which is hard to map to cloud. So it's a little bit of a complicated thing out there, but the main thing to understand is benchmark your own workloads and sort of like understand what workload needs to go where. But the main thing I want to stress is the case of the missing benchmark. So surprisingly, what I've noticed is ETL workloads a lot of times don't get that much attention, even though like a lot of people spend a bunch of time on it, right? Because the problem of computing derived data sets out of all the data that your company is collecting every day is very different from trying to answer a kind of like a more selective query where you're trying to figure out, okay, give me the sales for this region, or like a dashboarding problem like that, right? And actually, there's like a benchmark TPC DI for data integration, but I rarely see anybody reporting anything around it. And at least from our experience, what we've seen is, if you look at the patterns on the right, they depict like a fact table, an event table, and some dimension table being updated. You can see that the update patterns are really very different. We don't believe like all these workloads are same. So we need like better standardization, and this is something that I see regularly people hitting, but there is not enough out there in terms of standardized benchmarks to compare all of these things around. And finally, these data optimizations really do matter. And then we have very little here as well in terms of, okay, how does file sizing affect query performance? Like, do you take more hit on the write versus the read? And how do like, and then as we've seen, right, these are two studies of how clustering can improve performance. One from like on Hudi, one from AWS, one is from our own blogs on open source. Yeah, you can carefully control data layout, but how do you do it across like hundreds of tables without kind of really, having side effects? How do you globally optimize for cost and by data layout control? These are like pretty open problems, and like a lot of people have to hand tune and spend a lot of time today to like squeeze value out of these techniques. So I want to basically summarize and just like leave you with some food for thought, right? In all, what we're saying here is, the warehouse stack is more closed. The lakes are more open. Conditions apply, meaning like really depends on how you're building your lake. And it's built for, BI predominantly, and, things like lakes. If you look at every like large tech companies who built and adopted lakes, it's proven out, right, that they have the scale and the support for advanced analytics or data science. They're by and far fully managed. And here, what you'll find is I do routinely find that it takes like few months for people to even in the Hudi community, we have like a like a streaming ingest service and a whole bunch of things, but you still need to take it, learn it, operate it. You need to like there's a ramping curve for people, so it's like DIY and a little bit difficult to operationalize, I would say. And here, it's expensive as you scale, but it's cheaper as you scale. Meaning when by scale I mean your workloads get more heavy, or your data volume grows, or your R grows. So this is what the common pattern I see and this is a question that I've been asked a lot, which is like, when do people adopt a lake? So commonly you start like this, right? It's a very simple, replicate your operational data in, and then you have some dashboards. So most people are happy there. And then even with like modest data size growth, then you start getting into doing some ETLs on the warehouse. Then eventually, you either hit cost, or the company is big enough where you care about openness, open formats, all of the stuff that we talked about. And you form a data science team here, and they'll tell you that, oh, let's go instrument the app with lots of events. And this I've seen a lot from my time at Confluent, and also with the Kafka experience over the years. And mostly you'll see that the event data lands on the lake, and then you start writing some ETLs which need to be fed some data from the warehouse. You also copy any ETLs that you offloaded from the warehouse, you start copying the data back as well. So most people are in this kind of like world where there isn't a single source for lineage for your data. So we feel like instead of like polarizing the world into these kind of like two camps, like if we take a step back and think about from a user like organization standpoint what we would need, I would distill it down to like these kind of like 5 pillars, which I've seen again companies eventually come to realize and adopt. One is interoperable. So the lakehouses have to be interoperable even with like warehouses. Like, why not? The data is there. You should be able to. It's another engine that can query. So why shouldn't you be able to do that? And across all lake engines, like you should be able to access the data, right? Cross-cutting, because today, if you look at these 3 things, there's at least 3 ways to buy this, right? Or use it, like open source, or there's usually a company behind some of these engines, or directly from the cloud provider. They'll offer you a version, like a packaged version, right? And there should be easy uptake for new tech. Like, vendors shouldn't be controlling a lot of the interop as much today as they are, because these formats and these kind of low-level pieces become kind of anchor points to build sort of like some sort of like lock-in, right? So and more and more keep data on the lake. By that, what I mean is like open data formats. We've seen vendors sort of like rise and fall, but the data sits there, right? And I think overall, I feel in the last 5 years, I've seen that replicating your database changes or your raw operational data directly onto the lake in an open format sets you up really well for the future, because it's the most voluminous data sets usually. Even on the warehouse, what usually affects your cost is the raw ETL to like in the first layer of landing it into the warehouse and then doing a dbt to get your tables. That's the ETL cost that I've seen. So this sets you really up for that, and you can always recompute anything, right? You can switch query engines, you can recompute. You get this like really great flexibility in this architecture. And most importantly, I think this is like very understated. This now feeds a single source of truth, meaning like the same data feeds into both BI and your data science teams, which means like they can just worry about the data. Like they don't have a lot of these data quality surprises. They can just focus on like how their analysis is wrong or the query is wrong, rather than about whether we were fed different inputs. And as much as possible, we can manage a lot on the lake because it doesn't need premium compute. A lot of these management services are more like IO bound or external interactions. Not all the SQL optimizations don't really count, right? And yeah, we need a lot more here in terms of management. And again, we live in a world of specialized engines, so we really need to plan for that. And external tables on the warehouses today, I don't know if they are on par with their native formats, right? So that needs to improve, and then we can have a world where we can have also cost-effective ETL, where we leave the big batch jobs on the lake and then going back, right? All your raw data, most voluminous data sets are in open format on the lake. And you can write like small ETLs anywhere. It's fine, like they're but by and large, I think we should move more towards an incremental model. Still, you're writing batch ETLs everywhere, right? So what does it look like? It looks like this. You go directly to a Lakehouse, and it's like open. It has all the interoperability, and you can write ETLs there in a cost-effective way. It's already ML data eng ready. And then if you can get the data in quickly, even your ETLs and the ETL data out into the warehouse or directly query them, you're going to get like really good performance for BI and reporting. And you can even explore a lot of these new, ML or even streaming, like a lot of these new emerging areas can be well integrated, because again, it's an open format and the ecosystem can evolve on its own, not beholden to vendors. And yeah, of course, like this is proven out to support data science and engineering, right? So this is what like I've seen a lot of companies like kind of settle over. I'll be happy to take more of these questions right after in the office hours as well. And yeah, thanks for being here. And I know some of these slides came out a little wonky, so I apologize for that. I don't know what happened, but yeah, that's it from me.